squared minus 3x plus 1, and the given point is 3 comma 0. Is that true? 9 minus 9 is 0. Natural log, yes, it's 0. Correct. So they want us to find the equation of the tangent line to the curve at a given point. Okay, perfect. So you understand why this is so important. Remember, this is the equation that approximates the function near this point. Now we know, because we know we went through 3.10. That's why the equation is so important. So y minus y1 equals the slope times x minus x1, where this is 3 and this is 0. But I have to find this, which is basically dy over dx when x is 3. This is what I need to find. So can anyone give us dy over dx or y prime or f prime of x? That's all I need for this function. Can anyone refresh our memory on how to differentiate natural log of a function?
Being 1 over the function times the function prime.
Yes, times 2x minus 3. So all I have to do is find f prime of 3. So I have 6 minus 3 is 3, and this I know is 1. Because 9 minus 9 is 0, 1. So this is 3. So this will be 3x minus 9. So then y equals 3x minus 9. This is the equation of the tangent line to the graph of the given function at 3 comma 0. And this is the equation of the tangent line, right? We said, what was the next one? I said 5366. So let's take a look. Let's look at 53. Do we want to work on 53? Is 53 okay?
Yes.
Okay.
Yes,
Okay, 53 in 3
oh,
dots.
yes, careful.
So then we have y equals cosine to power x. We're asked to find y prime. How do we do this? Anyone?
Take the natural log of both sides.
Absolutely, very good. So natural log of y equals x, natural log of cosine x. Please remember that is absolutely mandatory. There is no, sorry. So there is no other differentiation rule here to be applied. Good. And now we differentiate both sides. This, as you just told me, is 1 over y times dy over dx. Here we have to be very careful because it's a product. Function 1 prime is 1, so natural log of cosine x plus x times 1 over cosine x times cosine x prime, which is negative sine x. So then dy over dx, I have to multiply by y, but I'm going to write it as what it equals to. Natural log cosine x minus x tangent x. And this is it. Please remember these steps. They're very important. And please use the notation dy over dx so you don't get confused. Any questions on 53 before we continue with 66? Okay, I'm sharing 66. So this is the inverse tangent. This is not 1 over tangent, right? So we have y equals arc tangent x squared. And I always write arctangent. I almost never write tangent inverse because I think it could be confusing to some, and it's also easier for me to type up. So when we differentiate this, please remember, arctangent is 1 over 1 plus this squared times the inner function prime. Don't try to simplify, this is it. So this is 2x over 1 plus x to the 4th. That's it. Any questions? Okay, moving on. Back to 3.5. I think it's implicit differentiation. I selected 32. You choose whatever you want. If you don't want 32, we can choose something else. Is 32 okay, or you prefer something else? Okay.
32.
Okay, so x squared plus 2xy plus 4y squared equals 12. And again, the same thing, the equation of the tangent line, which approximates a lot at that area, at that point, of course. Okay, so of course, please remember this is a function of x. Differentiate 2x, x squared get 2x. A product, this is a product, careful. So the first function prime is 2 times y plus 2x, but the second function prime, dy over dx, plus 8y dy over dx, and 0. Remember, these terms have to be on one side and these on the other. Luckily, everything is divisible by 2. So I'm going to write x plus y on this side. And on this side, both will be negative, and I will factor out dy over dx. So this is x plus 4y. 2x divided by 2, 2y divided by 2, 2x divided by 2, 8y divided by 2. But since they have to be moved to the other side, both become negative. So then dy over dx equals x plus y over x plus 4y. Only now I will say fine when x is 2 and y is 1. 2 plus 1 is 3. 2 plus 4 is 6. So this is negative 1/2. Negative 1/2. Once again, 2 plus 1, 3. 4 plus 2, 6, 1/2. So then the equation, and I'll let you finish that one. So it's y minus y1 equals the slope times x minus x1, where this is negative 1/2. x1 is 2, y1 is 1. If you want me to finish it up, I can, but I like to continue and make sure that we go back to 3.1. Is it okay if you just do the algebra on this on your own? Is that okay? Okay, thank you. So back to 3.4. In 3.4, I selected 31, but we can choose anything you want. So in 3.4, where are you? 3.4, right here. And I chose 31. Why did I choose 31? Oh yeah, I know why I chose 31. Is 31 okay, or you want to choose something else?
$31 is good.
Okay, I'm going to change it to x. It's easier for me to write. So x squared minus 1 to the third and 2x plus 1 to the fifth. So they're asking us to find the derivative and fully simplify it. Let's see what we can do with this. So h prime of x, the denominator is squared. The top prime, 3 x squared minus 1 squared times the inner function prime times the denominator. Minus, watch me run out of room. X squared minus 1 to the third times 5, 2x plus 1 to the fourth. Yay! I was able to squeeze it in, times the inner function prime. Don't try simplifying. Don't cross out anything. Remember, we have to factor first. So a 2 is out. This one. A x squared minus 1, power 2, power 3, it has to be 2. 2x plus 1, power 5, power 4, so it has to be 4. Two is out, but there is an x left in with a 3. This is completely out, but there is 1 left over here. This problem is extremely important for what follows in chapter 4, so please. 5 is still in, 2 is out. 1 is left over because I only took out 2 instead of 3. And these all 4 are out. So only now I can do this. So I have 2 x squared minus 1 squared. So this is 6x squared. And this is plus 3x. And minus 5x squared and plus 5. And 2x plus 1 to the 6th. Please practice. This is extremely important. So 2 x squared minus 1 squared. This is an x squared plus 3x and plus 5. Over 2x plus 1 to the 6th. Do not try anything. This is it. Back to 3.3. In 3.3 I selected 14, 30, and 50. You choose, of course. So in 3.3, 14, 30, and 50. Why? I don't remember. $14. Okay, I see 30. Same thing, finding the equation. So we can just differentiate. So we can finish with 3.1 and 3.2. And then 50. Why did I select 50? What does 50 say? Do whatever. 50. Oh, yes. 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 So 14, 30, and 50. Can we start with 50? In 50,
Yes.
we have limit as x approaches 0 from 1 minus secant x over 2x. We're asked to find the limit. What is our first step whenever we're asked to find the limit? What is the first thought? The first idea comes to mind. Plug it in. Awesome. Thank you. Thank you. So secant of 0 is like cosine 0, so it's 1. So the top is 0, the bottom is 0. So 3 conditions have to be fulfilled. A ratio, limit, and 0 over 0 or infinity over infinity. For us to apply what? But only if these 3 conditions are fulfilled. Limit, ratio, 0 over 0 or infinity over infinity. Then I can apply something. What is it called? I know it's in chapter 4, but you are allowed to use it. L'Hopital's rule. All three conditions are fulfilled. One, ratio 0 over 0 or infinity over infinity. Both. We are going to look in chapter 4 at more sophisticated situations, the other indeterminate cases. So then I have limit Sx approaches 0. This prime is 0. This prime is negative secant tangent over this prime, which is 2. So now when I plug in 0, this approaches 1, this approaches 0, the answer is 0. Feel free to apply L'Hopital's rule. When it's applicable. Okay, let's look at 30. Is 30 okay? Without the differentiation, without the tangent. Because if we have time, we can come back. I just want to finish the whole set. Is 30 okay? Or you have something else? Okay, 1 plus, okay, sine x over cosine x. We're asked to differentiate. So remember, this is the quotient rule. So y prime is first function prime, top function prime is cosine x times the denominator minus the top times the denominator prime. Careful now. We'll try to simplify. Don't simplify. This is not a factor. Careful. So cosine squared, this changes the signs, right? So sine times 1 is positive sine x, and sine times sine will be positive sine squared divided by cosine squared x. How much is cosine squared plus sine squared?
1.
Very good. Plus sine x over, and if you factor this, so this is 1 minus sine squared, I realize that we can factor 1 plus sine x. This one is 1 minus sine x and 1 plus sine x, and these two will go away. So it's 1 over 1 minus sine x. Let's take a look